So hi guys, I'm me again. I'm Emperado. So our topic for today's video is about how light acts as a wave and a particles. For the physical science grade 11, week 4, quarter 3. Quarter 4, week 3. So before we start, we should know about light. So what is light? Light is a part of electronegativity spectrum that can be detected by the human eye. The electromagnetic spectrum has other parts as we are going to find out later. So, rays and beams of light. What is a ray of light? Light travels in straight lines. A ray is a direction of the path taken by the light. For the beam is a stream of light's energy. It is represented by the number of rays that may be parallel, converging to or diverging, as shown in every figures. So there are many types of source of light. So the human eye can only see objects if light from it enters the eye. So there are two types of objects. So luminous sources, objects that can be their own light. Example are the sun, lamps, fires, and candles. And for the non-luminous object that can be reflect the light from the luminous sources, example by our books, mirrors, tables, and you and the moon. So the laws of reflection. As mentioned above, light can be reflected from the luminous object. This reflection, among other things, that allow to see images in the mirror. So you should take note that the following from the above diagram, the iridescent ray is the ray that light approaching the mirror, and for the reflected ray is the ray that light leaving the mirror, and for the normal is the line that can be drawn perpendicular at the right angle to the surface of the mirror. So the normal line divides the angle between the incidence ray of the reflected ray into equal angles. The angle of the incidence is the angle between the incident ray and the normal. The normal of a reflection is the angle between the reflected ray and the normal. So first of the law of reflection, the incident ray, the reflected ray, and the normal drawn that point incidence all lie in the same plane. This means that they can all be drawn as a flat sheet of paper. And for the second law of reflection, the angle can be incidence is equal to the angle reflection. So note, the common mistake is to measure the angle of incidence or reflection from the source of the mirror. You must remember that the measure from the normal exercises from the normal rather. So for the refraction of light, refraction is a bending of wave when it passes from one medium to another. The bending is caused due to the differences in tendency between the two substances. So the change of speed results in changing direction. A light of reflects whenever it travels to an angle into a medium of different refractive index. This change in the speed result in a change in direction. As an example, consider air traveling into water, and the speed of light decreases as it continues to travel at the different angle. For the loss of reflection of light, the incidence of refracted ray and the normal to the interface of two media at point is incidence all lie on the same plane. So the ratio on the size on the angle incidence to the sine of the angle of the diffraction of constant. This is also known as Snell's law of refraction. Refraction of light in a real life. Mirage and looming are the optical illusions which are a result of refraction of light. A swimming pool always looks shallower than it is really because of light coming from the bottom of the pool bends at the surface due to refraction of light. Formation of the rainbow is an example of refraction as the sun rays bend through the raindrop resulting in the rainbow. So while the white light passes through the prism, it is split into a component colors: red, orange, yellow, green, blue, and violet due to the refraction of light. So in the application of refraction of light, refraction has many applications in optics of technology. A few of the prominent applications are listed below. So the first is a lens uses refraction to form an image of an object of the various purposes such as magnification. And first is spectacles worn by the people which defected vision uses the principle of refraction. And for the third, refraction is uses per holes of house doors, cameras, movies, projectors, and telescopes. So there are so many questions that how do protons relate to light? So what is exactly is a proton? Let me tell to everyone that a proton is the smallest decreased amount of or quantum of the electromagnetic radiation. It is the basic unit of a light. So protons are always in motion and in a vacuum. Travel of the constant speed at all observed as 2.998. So you times it into 108 millimeter per second. Meter per seconds. Minute or seconds rather. This is commonly referred to as the speed of light, denoted by the letter C. So protons, properties of protons, the basic properties of the protons are they have zero mass and rest energy. They only exist as moving particles. They are elementary particles despite lacking rest mass. They have no electric change. They are stable. They are spin 1 particles, which makes them bosons. They carry energy and momentum which are dependent on the frequency. So they can have interactions with other particles such as electrons, such as the compulsion topics. They can be destroyed or created by many natural processes. For instance, when radiation is absorbed by emitted, when it empty space, they travel speed of light. So in the history of the protons, the term of protons is coined by Gilbert Lewis in 1926. So though the concept of the light is from the decreased particles had even around from the spectrums and have been formalized and Newton's the construction of science and optics. So wave of the particles dually in the brief. As mentioned above, the light has the properties of both wave and particles. This was the astounding discovery and certainly outside of the realm of how we normally perceive things. So, in billiard balls acts as particles while oceans acts as waves. So protons act as both a wave and the particles all the time. Even though it's commonly but common rather, but basically incorrect. To say that it's sometimes a wave and sometimes a particle, depending upon the which features are more obvious and given time. So just once of the Earth. Ay. So, take a briefly, and there are two methods of protective from UV. So, first, simply prevent long exposure and stay out of sun or cover yourself when out in the sun. So, use sunscreen containing chemicals like PABA, which is absorb UV light and convert it into heat. So, it shields the DNA in your cells and you don't burn. But don't stay in the dark. So either UV light synthesize vitamin D in your skin. Children who don't make enough vitamins D and rickets, the people need to get little sun or take a vitamins supplement. So now we can see colors. How we can see colors? So in the human eye, the brain together that translate light into a color. So light receptors within the eye transmit messages to the brain. So which produces the familiar sensations of color. So Newton observes that the color is not inherent of object, rather than the surface of object reflect same colors and observe at the others, we perceive that only refractive colors. That's all. Thank you for listening for our discussion. And once again, I'm Irish Jane Emperado. Thank you and God bless. Happy learning!